Thanks everybody for joining us today. We're going to spend the next couple of days talking about preservation and pavement maintenance. And let's see if I can get this to advance. So we've gone through some of our housekeeping here. Our length of workshop today, we're going to run till about 11 o'clock. This is a big workshop, so we're trying to streamline it and make sure that we get through all the material. Lori's talked to you about the attendance and then also workshop. I think the good news is there's no exam at the end, so you'll like that. Okay. So let's go ahead and get going here. We've got some polling questions that we're going to give you, and here's the first one. We're just kind of interested where you're joining us from, so I think if we can pull up the polling.
Oh, that's right. Let's see.
And so we're interested to know if you're from North Idaho, Southwest, around the Boise area, South Central, Twin Falls, or Southeast. If you can just take just a couple of minutes and click on the button that applies to you and submit it, then we'll find out where everybody's from. Okay, how's it going? Let's see, Lori, are you muted?
Yeah, sorry, I was.
Okay.
I have a dog that's making sleeping noises or running in its sleep in the background. So it looks like we have 25 out of 26 who have participated. So almost everyone. If you'd like, I can go ahead and end the polling and we can display the results.
Yep, that'd be great. So you can see we're scattered around the state pretty well. Looks like the Southeast is a little bit low there. Southwest is taking the lead. But I just wanted to kind of get a sense of where everybody's coming from today. So appreciate you answering that polling question. So here's what we want to cover today. We're going to start off with a conversation on pavement preservation and management. And then we'll progress on during the day, probably get through a lot of distress identification and how pavements distress and how we can view that. We'll talk further about potholes and cracks and how we need to address those. Talk about surface treatments, and in particular, we'll end up talking about chip seals. So let's talk about pavement preservation and pavement management to begin with. And so when we look at our roadway, we're very interested in kind of knowing how things are named. So we start at the top with the surface course, and most of our roadways in Idaho are asphalt. Some people call them plant mix pavements, but we commonly refer to them as asphalt. So our top course is this surface course, and below that we have a base course. Usually it's like a 3/4 inch or a 3/4 inch minus type of gravel. And below that layer, many times a sub-base course, which can be optional, is put down. And it's like a bigger aggregate. It's like a 1 inch, 2 inch aggregate. It's very, very coarse. And it adds strength to the roadway. And the layer below that is the subgrade or existing soil. And sometimes we have really good soils to work with, natural soils. And sometimes we've got really crappy soils to work with. And so we'll kind of go over that and how the roadway is designed to a certain strength. So I just wanted to kind of give you an idea of what we call these various layers of the roadway, because we'll refer to them as our day goes on. So pavements are like the hat for the ground. You know, they keep the water out and away. And in addition to that, they spread out the load. And it's good to spread the loads out, or we'd be all driving on rutted pavement. So we're also keeping the original ground dry, which is important, especially where the ground is soft and it doesn't drain very well. We don't want to wear away materials that we have in place. We could also be faced with some environmental issues if we were washing a lot of material off the roadway and into various drainage systems and various streams.
Brent? Your voice is fading just a little bit. I'm not sure if there's a microphone that needs to be adjusted.
Okay, how's this?
That's great, thank you.
All right, okay. So it's important to start the road building process with good materials, especially if we're rebuilding the road or we're putting in a new roadway, that are properly sized. So a sieve analysis allows us to break the materials into various sizes, and it provides a means to specify materials. So if we're building a brand new roadway, typically we'll put into our contract, or we'll put in somewhere where we're specifying that we want a certain size of material. So soils are generally classified into gravels, sands, silts, and clays. So a sieve analysis, or a gradation test, is the procedure used to assess the particle size distribution or gradation of a granular material by allowing the material to pass through a series of sieves of progressively smaller mesh sizes. So we take and we scoop up our sample, and we've got our stack of sieves, and we dump it in there and we shake it, and material is retained on each sieve. And so the gradation is determined by the percent of material passing each sieve. So the size distribution is it's really critical importance to the way the material performs in use. A sieve analysis can be performed on any type of soil. So I guess, and we're not live here, so I can't really get a lot of feedback, but I'm really curious if anybody has ever been involved with or has been using sieves or does sieve analysis. So I don't know if you want to type something like that into the chat room and let me know. But it's very important that as we build roadways, that we have some kind of way of classifying the material, and sieve analysis is really the best way to do that. So this just gives us an idea of what the sieves look like. Sieve sizes are given in inches. From the 1/4 inch on up, it's denoted by inches, and from the 1/4 inch on down, it's measured by the number of wires per inch in the sieve. So if somebody comes up to you and say, I have a number 30 sieve, that means that you've got 30 wires per inch. All the way down to the most finest sieve is number 200, which is 200 wires per inch. So it's pretty fine material. So you can kind of see from the picture what the various sizes of the sieves look like. So it's important to have material that does not swell. Swelling material really kills us because it heaves the roadway. Why wouldn't you want too many fines in the base material? Well, excessive fines will hold moisture and weaken the base. So when the base fails, no amount of pavement preservation will help you out. So when we put down the base course, and remember that's the layer that is below the asphalt layer, we want it to be able to drain really freely. So we don't want a lot of fine material. And that's why sieve analysis is very important if we're specifying like a 3/4 inch minus gravel base. So as we look at some of our desirable properties for asphalt pavements, aggregates used in asphalt mixes, we want them to be hard, really hard inert materials, such as real good crushed gravel. Properly selected and graded aggregates are mixed with asphalt cement to form asphalt mixtures. And I commonly refer to it like just mixing up black goo and rocks, okay? Aggregates form the principal load-carrying component of the mix. And typically in the asphalt mixes, the aggregate makes up about 90 to 95% of the mix. And so asphalt ranges typically are in the 6%, 7%, sometimes 5% range. So you can see that most of our pavement is made up of aggregate, and that's where we get most of our strength, because the aggregate, if it's well graded and it's angular in shape, has a point-to-point contact. And if you add up it's amazing. If you add up all these little points, it really makes the pavement really strong. So aggregates containing foreign matter such as vegetation, soft particles, clay coatings, clay lumps, and so on are not satisfactory to use in asphalt pavements. Clean soils will have less than 5% fines, and dirty soils will have more than about 12% fines. So when we put our asphalt pavement together, we want material that's really well graded. We don't like a lot of fines in there. That really lends to its strength. So we want a really carefully controlled gradation. So that's why sieve analysis is really important in being able to put together our pavement mixes. So here's polling question number 2. Let's go ahead and bring that up. Does your agency have gravel roads?
Brent, I think we're having a little technical difficulty from that one. You
Okay,
have these pre-filled, so I don't have that question up right now, but the next one that I have is about the pavement management.
okay, all right. Well, we'll just go ahead and move on then.
Okay.
But I think, probably most agencies out there have some gravel roads in their inventory. So a good road really depends upon good design, good maintenance, and good construction. And so roadway designs, those various layers are designed to carry the road, and we want to make sure that those are designed properly. Good construction is if you have a contractor that's building a new road for you, you want to make sure that they're doing a good job and that you're able to take appropriate tests for aggregate material sizing, such as sieve analysis, good compaction, because once the designers leave the job, once the contractor leaves the job, contractors typically don't warrant their work. You have to take it over. And so a good road depends upon good maintenance. But it's incumbent that you inherit something very good to begin with, or else you've just got a maintenance headache on your hands to start with. So it's important to protect the roadway because we can all agree that our roadways are a huge investment. So I want to talk just a little bit about pavement management. You know, pavement management is to gain the insight on the history of the pavement. So we want to know what the history of the roadway is, when it was built, what the various layers look like, if we can get our hands on that, how thick they are, what type of material is in there. And we want to be able to try to measure deterioration. Pavement management systems are now used to track pavement deterioration and to select the best pavement preservation options. And so when we talk about pavement management systems, you know, sometimes you'll get people that will bomb through the door and want to try to sell you a pavement management system. And it doesn't have to be very complex. You can go out and actually kind of create your own management system simply just using a spreadsheet, a simple spreadsheet, and I'll show you that in just a moment. So budget planners and managers want to know how much money it's going to cost to maintain a pavement to a certain condition level so proper planning can take place. We want to know about the roadway and how we can obtain the longest possible service life at the lowest possible cost. We want to know how many dollars it's going to take to maintain the roadway back to a desirable condition. And we certainly want to provide the public with safe roads. So in the past, history, and without some kind of management systems, roads got maintained either by a worst first or prioritization through some kind of a politics process. Maybe that takes place even a little bit today. Hopefully not. But worst first usually resulted in allowing the roadway to deteriorate to a point of complete failure, and then it got rebuilt. So do you think any one of these strategies would result in the most efficient method for pavement management and the expenditure of tax dollars? Not really, but before agencies got into pavement management systems, this was the way that they did business. You know, we're going to go ahead and attack it worst first, which means we're going to spend a lot of money to fix the roadway that is in the worst shape, or perhaps you had some politician telling you where you're going to go spend your money and what you're going to go do first. But we can do better than that. So pavement management systems came along to kind of help us prioritize our work. And without some kind of pavement management system, we really never knew if you were making progress or falling further and further behind in the maintenance of your roadway network. So determining if progress is being made just was really kind of a bit of guesswork, because there was no procedure for determining if funding was improving the roadway or if we were just allowing it to further deteriorate. So we needed an approach that would be quantifiable and objective. We could kind of wrap our hands around it. We were able to predict what pavement would do in the future as far as deterioration goes, and that we were able to recommend cost-effective pavement treatments so we could ensure that the money was being spent wisely. And we weren't just going to let the roads fall apart and attack them from the worst first scenario. We were going to try to preserve the pavement as it started to deteriorate. So in order to get out of that rut, a new approach needed to be developed. So computers came along and they really had the ability to perform some kind of pavement management capabilities. The research has really shown us that it's far less expensive to keep a road in good condition than it is to repair it once it's deteriorated beyond hope. This is why pavement management systems place the priority on preventative maintenance of roads in good condition rather than reconstructing roads in poor condition. In terms of lifetime cost and long-term pavement conditions, this is going to result in a better system performance of your roadway network. So highway districts that concentrate on restoring their bad roads, sometimes you often find yourself just kind of circling into a black hole, that you're restoring your bad roads, and then by the time you've restored that road and spent all the money on it, all the rest of the roads have kind of gone downhill to the point of no return. And now you have to jump over to those roadways and fix those. And so really you just kind of get into that vicious cycle. So hopefully pavement management systems will help us determine the place to spend our money. And so I want to talk just a little bit about preserve in the roadway versus the reconstruct worse first. It's been shown that years of pavement condition data shows that it is more economical to preserve the roadways rather than delay the repairs. And as traffic levels increase, the cost of delaying repairs increases dramatically. I'm going to show you that in just a moment. It's just not a linear relationship as far as the deterioration of the roadway. It gets to a certain point and then just really drops off. So repairing the worst roads first is a very expensive way to operate your roadway system. So my next polling question, if we can bring that one up, is does your agency currently use some kind of a pavement management system? And remember, these can be things such as a simple spreadsheet. It doesn't have to be a sophisticated operation. So let's just take a moment and answer this polling question.
All right, so the question we have come up is, does your agency use some type of pavement management system? And there's the option of don't know, if maybe that's not really your area of expertise. All right, I think we've got everybody on there. So we're gonna share that.
Wow, that's good. That's good to know that you do have some kind of a pavement management system. It looks like 69% of you, or almost 2/3 of you, have some kind of a system. Some don't, and some don't know. So, but that's really good. So I want to kind of just back up for just a moment here, talking about this preserve versus construct. Pavement management approaches, the following management approach evolved over the last, say, like 30 years, and it's a process that consists of the following steps. So when we look at a pavement management system, we're very interested in inventory of the roadway and the definition. We're very interested in looking at the pavement and inspecting the condition of the pavement. So we do some kind of a condition assessment. We're very interested in trying to predict the future. In other words, can we get our hands around how fast the pavement is going to deteriorate? And can we do some kind of a condition analysis? If we look at all of those things, it perhaps helps us better plan our work. So this is kind of the curve that I was talking about. And so let's just take a moment and look at this. It's the cost of pavement deterioration. And don't pay so much attention to the dollars on the right-hand side, other than the fact that if we fix the roadway earlier in its life cycle, it costs us a lot less to do that. So let's take a look at this curve. On the bottom is the time or service life. And so we start at 0 on the left-hand side, and then as time goes on, it becomes the service life of the pavement. The axis, the vertical axis, is the actual condition. So if we start at time 0, we're going to have a new pavement, and that makes a lot of sense. And so as time goes on, pavements will start to deteriorate. And it's almost kind of like your brand new car that you drive off the lot. As soon as you drive it off, it starts to deteriorate. Once you've built your house, it's going to start to deteriorate. So pavements are going to start to deteriorate right after you build them. And so as time marches on, the curve starts to drop off as far as the condition because the pavements start to wear out. And when we get to that, about that 30% quality drop point, it's a lot less expensive to repair those pavements and bring them back up to a like new condition rather than just let them go, because as you can see on the curve, it's not a linear relationship. It drops off dramatically. And so over on the right-hand side, we say for each dollar of repair not done here, it might cost you $8 or $10 if delayed down to the point the pavement is failing. So you can say, well, it's like the Fram oil filter guy, pay me now or pay me later. But it's amazing that pavements get to a certain point and it's not a linear relationship, that they just really drop off and will deteriorate quite rapidly if we don't maintain them. So the problem is that pavements will deteriorate and those costs will increase dramatically if left unchecked. So what causes the deterioration? Okay, so we have two big causes that come to mind. The first cause is environment. And I know we're not all together here, but we can think about the environment as like the weathering of the pavement, or oxidation is a term that is commonly used. The second big cause of pavement deterioration is the traffic loading. And we can kind of all agree that, the traffic is increasing all the time. I know in the area of the state where I live, traffic is going up quite substantially, especially truck traffic. Utility cuts will cause the pavement to deteriorate. And in fact, many agencies I see have policies in place whereby if we overlay the road or we're putting down a new pavement, that unless there's some big extreme emergency, we're not going to allow the utilities to cut the pavement for a certain period of time, or we won't allow any cuts. Sometimes it's like 3 years, sometimes it's 5 years, so every agency kind of has their own set of rules. And then the other last major cause of pavement deterioration is poor design or poor construction. So the pavement was under-designed, it's not going to carry the load properly, or you had crappy construction take place. And so that's why it's really important to have good design, somebody that knows what they're doing to design your pavement and design those various layers, and not only select the good type of material to put in those layers, but also the correct thicknesses so you can carry the traffic loads. And it's also really, really important to have good construction in place and good construction testing, so you can go out and test the materials, you can test for compaction, and make sure you're getting a roadway that you're paying for. Because once the design is done and once the construction is done and the contractor leaves, you are pretty much just kind of stuck taking care of this road. So the symptoms for deterioration of pavement is just visible pavement distresses or defects. And we can also measure, and we'll show you later on, we'll also be able to measure the amount of deterioration or the level of deterioration. And we can certainly measure the strength of existing pavements. So some of what we want to learn about is, we want to talk a little bit about the various terminology of distressed pavements and how we can go about identifying those various types of distresses to our pavements. We want to talk a little bit about the differences between preventative and reactive repairs. And we also want to understand some of the basic pavement maintenance management concepts, like monitoring the pavement condition and trying to look at the pavement life cycle and predict what that life cycle might look like. So here are some questions that we want to ask ourselves. We want to ponder the following. What is pavement preservation? We want to talk just a little bit about what is preventative maintenance and what is corrective maintenance, and what is the difference between the two? When should these actions be taken? are these actions of pavement maintenance management effective? And why doesn't agencies, perhaps maybe your agency, have a pavement management preservation type of program? So these are just some questions to consider and ponder as we go through our slides. So AASHTO is the American Association of State Highway Transportation Officials, and they have come up with kind of a bit of a strategy definition. The planned strategy of cost-effective treatments to an existing roadway system and its appurtenances that preserves the system, retards future deterioration, maintains or improves the functional condition of the system without increased structural capacity. So that's kind of their definition of effectively maintaining or preserving the pavement system. And so when we talk about structural capacity, we're talking about adding something to the roadway that will increase the load-bearing capacity of the roadway. So when we talk about preventative maintenance, we want to talk about planned maintenance. Okay. We want to talk about maintenance that's performed on good pavements. We talk about contributions to the long-term performance. And so when we think about preserving the pavement and doing preventative type maintenance, some things come to mind. Some of the things that we use out there that perhaps you're using today, some examples are like fog seals, chip seals, and maybe putting down some kind of a thin overlay or thin hot mix asphalt overlay. And this helps prevent deterioration of the roadway. And so we can think of preventative maintenance as being proactive. We're out kind of ahead of the curve. We're out there, we have a good pavement management system into place. We can see the pavement is starting to deteriorate, and we're going to go ahead and preserve it through prevention, which is proactive, and stay on the top part of that curve because it's going to cost us a lot less money than if we just let the pavement go. Corrective maintenance, we can think of corrective maintenance as reactive. Yeah, we're performing some maintenance on pavements that are failing. A lot of times reactive type of maintenance does not contribute to the long-term performance, and it's going to cost us a lot of money to bring that pavement back up to a like new condition. So some examples that we find ourselves doing that is of a reactive nature is such as patching and pothole repair. So when we look at the system as a whole, it is concluded that preventative pavement preservation is a combination of corrective maintenance and preventative maintenance. And so that really kind of those two categories put together gives us our pavement preservation program. So the National Highway Institute comes up with a little bit of a phrase here that kind of sums everything up. It's the sum of all activities undertaken to provide and maintain serviceable roadways. This includes corrective maintenance and a preventative maintenance, as well as minor rehabilitation projects. And when we think of minor rehabilitation projects, we might think of those thin lift overlays. So when we look at undertaking the work to extend the service life of our existing pavement, this does include restoration, such as placing an overlay. It also looks at other work required to return the roadway to its existing or original condition. And so we want to put the work in that is required to return the existing roadway to a condition of structural and functional adequacy. And so when we talk about the structural adequacy of the roadway, we're talking about the load-bearing capacity. When we talk about the functional aspects of the roadway, we're talking about the things that like lane width, those types of things, and how the roadway functions. So I just want to show you a picture here. And this is a brand new hot mix asphalt pavement. Okay, it's been put down very recently, and it has it's showing really no distress at this point in time, and it really shouldn't because it's a brand new pavement. Is this pavement a good candidate for preservation maintenance? Well, the answer is probably yes, because it's young in age and it's in excellent condition. But once again, once you put the pavement down, it will start to deteriorate from the very first day forward. And so we want to be able to monitor the pavement through good pavement management system and look towards the future and try to predict how long it's going to take to start deteriorating so we can do preventative maintenance rather than that reactive or corrective type maintenance. So the pavement structure is stable with no cracking. We don't have any patching going on. We have no deformation. Roadways in this category are fairly new and riding quality is excellent. So nothing would improve the roadway much at this time, but we really want to put it into our pavement management system and start watching it and be prepared to do those preventative maintenance actions. So, and this is where we take the, by the way, this is where we kind of take the biggest hit sometimes, is if we go out and we start doing work on the pavement and doing preventative maintenance work, sometimes the public might perceive us as saying, why are you going out there and working on something that appears to be brand new? But yet, when we look at things, we know better. We look at how the pavement is deteriorating. We know it's going to start cracking, maybe hairline cracks, maybe some minor rutting and so on. But the public really doesn't pick up on that. But because we do, you know, we're all the experts out there. If we can attack this, you know, we're actually saving the poor old taxpayer a lot of money by attacking the roadway in a preventative fashion. So I want to show you this roadway. This is an older pavement. It's still in pretty good condition. Is this pavement a good candidate for preventative maintenance? Yeah, it is. It's fairly stable. We've got minor cracking that's starting to show up. Generally kind of hairline cracking. It's a little hard to detect unless you go out and walk the pavement. But we might have some, you know, minor patching that we need to do. Possibly some minor deformation is evident. We've got a lighter. You can notice the pavement is a lighter or dry, or looks kind of dry. And remember, we have had 4 categories of pavement deterioration. The 2 top ones were environment and load. And so when we see a pavement, it's starting to get brown like this. It's starting to oxidize. So the environmental aspects are starting to deteriorate the roadway. Okay. So when would you expect to see further deterioration, in how many years? And when would you expect to say, apply your first preventative maintenance? So, you know, these are questions that we have to ask ourselves. And again, if we're put this pavement into a pavement management system, we can try to start predicting the future and try to think about what are the things that I'm going to have to go out and do to stop the deterioration of the roadway and try to bring it back to that newer condition. Let's take a look at this picture. Okay. This is a hot asphalt mixed pavement, and it's showing some significant fatigue cracking in the wheel paths. Is this pavement a good candidate for preventative maintenance? Not really. It's we're kind of getting past the point of no return, and we're kind of going into that corrective or reactive mode of maintenance. This pavement is not a good candidate for preventative maintenance, and as it's experiencing what would be appearing to have starting to have some real structure issues. It's starting to deteriorate from a structural standpoint, and so it's still functioning well from a functional standpoint as far as the width of the roadway, you know, lane width, the operation of the roadway. But as far as the load bearing capacity, we're seeing failure that's starting to take place. Okay, so we've kind of passed that preventative maintenance window of opportunity, and we're finding ourselves further down that curve into a corrective or reactive type of maintenance, and it's going to start costing us quite a little bit of money. So we kind of think about this when we look at a roadway like this. Are there things that we could have done earlier in the road's life cycle that would have brought it back to a like new condition? And the answer is yes, we could have done that. So when we look at this, we can kind of put together a little bit of a matrix. Okay, what are the different types of maintenance activities that are part of pavement preservation, and how do they differ, planned versus not planned? And so when we look at this, we can define the different types of maintenance. So we can think about routine maintenance, and we can think about it along the lines of it's kind of a scheduled day-to-day maintenance activities, such as sealing cracks. So when we look at routine maintenance, it's in our work plan. We've got the pavement and our pavement management system. We're trying to predict the future, and we know when we're going to go out there and do certain things to fix the pavement. So do we work on routine maintenance? Do we do that before deterioration? Well, not necessarily. And does it extend the facility or the pavement life? Usually does. You know, we say sometimes, but that's usually the case. Reactive maintenance is thought about as unscheduled maintenance activities in response to events beyond the control of the maintenance organization. So, in other words, pothole patching, patching pavement blowups, unplugging drainage structures. And by the way, drainage is one of the biggest culprits of pavement deterioration, and we'll go over that a little bit later on. We can think of corrective as planned activities to repair deficiencies. We just restore those elements of the highway to its original condition or increase the service life of the roadway or those facility elements. Okay, so in other words, we're looking at doing partial depth repairs, patching of hot mix asphalt pavements, maybe some minor overlays. And preventative can be thought of as planned activities intended to preserve the system. And we note that these activities add functional, maybe not structural value to the pavement. Okay, so if a preventative maintenance technique does not extend the life of the pavement, it is most likely maybe not cost effective. So if we're going out and the work we're doing is not really extending the life of the roadway, perhaps we're not spending our money wisely. So again, there's our pavement life cycle curve, pavement condition over on the left-hand side. If we have a new pavement, as time goes on, both load bearing of the pavement, loading of the pavement, traffic, mainly truck traffic, environmental conditions will deteriorate the pavement. And again, we can see it's not a linear function that we get to a certain point, and if we just let the pavement go and we do nothing, the deterioration drops off pretty dramatically. So how do we measure all this stuff? Okay. Many attempts have been made to measure and track pavement condition. And it's just kind of, here are some of the few rating systems, if you will, that have been used. And so the first one that is used is called the Pavement Condition Index, okay? And so in this Pavement Condition Index, or PCI, 100 is excellent, and a PCI that equals 0 means your roadway has totally failed and has turned to rubble. Another measurement system that's out there to use as you do pavement management in your pavement management system is a Present Service Index, or PSI. And a PSI that's a roadway that's assigned a 5 is excellent. And if it's 0, it has failed. And the other one, which I don't think is as popular, is the International Roughness Index. And so you're rating the roadway surface smoothness, and you're trying to kind of gauge your roadway condition based upon smoothness. The public, that's the way they gauge you, is the right of the road. They feel the pavement condition in the seat of their pants. And remember, everybody that has a driver's license is a self-proclaimed maintenance engineer or maintenance person or traffic engineer. The public will judge you mainly on how the roadway not only looks but also how it rides. So the most popular, I'm just going to back up one, the most popular way of using the rating system, or the rating system that is the most popular, is the Pavement Condition Index. And it came about, it was invented by the Army Corps of Engineers, and it was developed mainly for airfields. And the ASTM, which is the American Society for Testing Materials, has developed standards for both highways and airfields. And so you can actually go out there, and if you look at the ASTM method for judging your roadway, as you build your pavement management system, you know, again, this is not rocket science. You can go out and just build a very simple spreadsheet. And if you use their methodology, you can actually determine if your roadway is in excellent, good, fair, or poor condition. based upon what you see. So you can analyze the distresses from the standpoint of the type of distress, the severity of the distress, and the density. We'll go over these in just a moment. And you can assign a value, and you can go out then periodically and look at your pavements. You can say, okay, I can see there's further deterioration. I can then kind of come back to our magic curve and really plan my work. And I want to do my work when I can do the preventative maintenance type of work, because it will save me quite a bit of money. So as we look at some examples here, we look at the distress type, and we think about distress type as either kind of like weathering or raveling, okay? We look at this distress severity in this pavement, it might be classified as maybe moderate. When we talk about distress density, we're talking about the total area of the pavement, and we would say in this case, in this example that I'm showing you, that the distress density is 100% of the surface. In other words, the surface is wearing away, the pavement is deteriorating in an even fashion over the entire surface of the roadway. And so when we look at this ASTM standard or method of trying to come up with a PCI number, we're going to be able to come up with a point system. And in this case, on this pavement, we're going to deduct 12 points, and we're going to have a PCI rating, and we're going to assign it a value of 88. So we come back to our magic curve. It's not too bad, you know. We're still in that top portion of the curve, that top 30% deterioration. And we would really want to think about doing some type of treatment to the pavement at this point, rather than to wait later as it deteriorates further and gets into that more corrective or reactive mode, which will cost us more money. So if we look at this pavement and we're able to use this method to try to determine the condition of the pavement through this pavement condition index, we do come up then with that value of 88. We say, okay, well, if I can do this with my roadways and throughout my entire network of roadways, then I can kind of get a feel for the condition of my pavement, and I can start planning my work, and I can plan my budget and think, okay, what do I want to attack first? You know, what do I want to attack second? And I really want to try to stay on top of things through that preventative maintenance mode. So when pavement condition, the critical PCI number is thought of right about the 65 or 70% range. It's like, you know, that's really going to start costing me a lot of money if I let this pavement go further without some type of corrective action work. So when I get into that 65 or 70 PCI number range, at this point, the pavement is really starting to deteriorate. And so again, notice that the curve drops off rapidly. It's not linear. And so if I let this roadway go much longer without some kind of preventative maintenance type of work, then I'm going to be in trouble, and I'm going to have to start spending some serious money, and it might do some bad things to my budget. So again, I can't emphasize this enough, is that, and this is why it's very important to try to develop some kind of a simple pavement type of management system so we can stay ahead of the curve and stay in the preventative maintenance range, stay away from that critical PCI number of 65 to 70, and stay out of this range of doing corrective maintenance, some rehabilitation, or worse yet, the roadway has deteriorated so bad that we have to do some kind of total reconstruction. So we can think of preventative maintenance again is if we put money into the roadway in the top portion of this curve and bring the pavement condition back up to like a like-new condition. You're never going to get back to brand new, but like-new condition. Then this is what our curve kind of looks like when we apply our dollars doing preventative maintenance. Corrective maintenance, we're going to start plowing a lot of money into our pavement, but we're only going to bring it back to a certain point, and it's going to start deteriorating again. So again, we start when we're in our corrective maintenance mode, we start chasing our tail around the room, and we're putting money into the pavement. And if we're not making improvements, marked improvements to the pavement from a structural or a functional standpoint, then we're starting to kind of waste money. So when we look at doing rehabilitation, so when we do corrective repairs, deep pothole patching, deep crack sealing, that type of thing, we're only going to bring the roadway back to a certain point. If we're doing a rehabilitation project, it's going to cost us quite a bit of money, like a overlay or a mill and inlay. We're only going to bring it back to a certain point. We'll certainly bring it back more towards that new condition, but we'll start to deteriorate again. And reconstruction, of course, will bring us back to that new point, but reconstruction is very costly. And so we find ourselves spending all of our money on reconstruction projects, and then we don't have any money left over to do preventative maintenance on the rest of our system. Pretty soon they deteriorate to a point that we have to do reconstruction there. And again, we just get into that vicious cycle. And so the whole idea behind the pavement preservation strategy is pretty simple. And again, if we can kind of have a system in place to kind of track the condition of our pavements, our big goal is to try to apply the right treatment to the right pavement at the right time. And that's a lot easier said than done. So when we look at pavement preservation benefits, okay, a nationwide survey of the public opinion was performed as part of a national kind of quality initiative on pavements. And it showed that only a moderate level of satisfaction with the highway system was given by the public, and it was noted that there is considerable opportunity for improving public satisfaction with the highway system. So the public is very concerned about how the taxpayer dollar is used and that makes sure that it is used in a cost-effective manner. So the public prefers permanent repairs rather than something that's temporary in nature, and that really only makes sense. So a reasonable expectation of preventative maintenance is that over time, you and your agency and the traveling public can expect improved pavement performance. This may seem backwards, but at times it is best to let pavements go and reconstruct them rather than throwing money down a rat hole. And sometimes we have to just recognize if the pavement has just deteriorated, the roadway has deteriorated so poorly, you're just better off to bite the bullet, let it go. You're going to have to plan something into the future and budget something into the future that takes you to a reconstruction project. And so that it seems kind of backwards, but more and more people have found out that that's kind of the best way to go rather than try to fix something that really can't be fixed. So when we look at further pavement preservation benefits, cost savings is certainly an intended benefit, but sometimes it's kind of hard to prove. Savings can be in terms of less expensive treatments, longer pavement lives, and or cost benefits to the roadway user, such as fewer delays and deterioration of vehicles and other roadway equipment. The real benefit is in the terms of the cost effectiveness of the treatments that may extend the life of the pavement. So if we are able to use less expensive treatments, extend the pavement life, we can enjoy some of those cost benefits. Safety is a top priority for users. Safety appears over and over and over and over again in surveys of users as their most important concern. They want safe roadways. So Idaho does have a strategic goal to reduce fatal and injury crash rates. If any of you have been to any of my other workshops, I've been able to talk about safety and what the cost impacts of fatalities and serious injuries are to all Idahoans. So safety can be improved by using treatments that are safer to operate on, by having better operating conditions and by eliminating repairs. And one of those benefits I think that everybody can kind of recognize are seal coats to increase the skid resistance, to increase the friction of the roadway, to help cars stop better and to keep cars on the roadway as they go around corners. So some additional benefits, here are some additional benefits of a preventative maintenance program. It can provide greater stability to both you and construction workforce. And what I mean by that is that if you get into a good preventative maintenance program and you've got a good kind of pavement management system to where you can look at your network of roadways and to try to determine when is the best time to do preventative maintenance actions, you're going to have more of a stable budget. Okay? You're going to have that pleasure of being able to spread your dollars around onto your network, make the poor taxpayer a little bit happier. You'll have a stable workforce if you're doing preventative maintenance benefits. And what I mean by that is you're going out and you're making a big difference. Everybody is not saying, why are we doing this? You know, what's the point? So you have a better workforce. Contractors will have more of a stable workforce because if you're hiring contractors to do the work, if you're doing it on a cyclical type of basis, they know that they're going to have work into the future. And so then you're less likely to be affected by the upswings and downswings. You're not, again, running around kind of chasing your tail. So here are some implementation challenges. One barrier to implementing preventative maintenance. So again, we're not talking about corrective maintenance. We're talking about just the things that we do in preventing roadway deterioration. But one barrier to implementing preventative maintenance programs is public perception, believe it or not. The public may not accept the move away from the worst first strategy. So in other words, if you're being faced with, gosh, I'm going to have to maybe let that road go because I just don't have the money right now to do it. I'm going to have to budget to do a reconstruction project into the future. They might not accept that strategy. You know, put another way, the concern is that the public is unable to place the general good above their own personal interests sometimes. So agencies only receive complaints about failed roadways. So if you go out and do preventative maintenance on some of those roadways that I showed you pictures of earlier, to where they actually look pretty good, but we all know they're starting to deteriorate. Either they're oxidizing or they've got some hairline cracks, you know, and so these are the things that we want to pay attention to. Sometimes the public doesn't realize that, and perhaps you might get criticized for being out there working on a roadway that the public thinks doesn't really need much attention, where the other roadway that you're having to let go needs the most attention. So, you know, you'll get this, why are we working on what appears to be good pavements and ignoring pavements that are bad? So that is one challenge to implementation. So you'll have public perceptions. Sometimes management perceptions are also present in implementation challenges. You know, a preventative maintenance program needs to have a champion that supports the change. And I will share with you recently with one agency that I was able to talk with quite a bit. They would go out and patch potholes, and they would do it, and I don't want to name the agency, but they would do it in a manner that really wasn't good workmanship, so to speak. But the theory was that the supervisor says, well, this gives you something to do and you're at least out onto the roadway and the public can see you working. And it kind of made me think. I thought, well, but are you really fixing the problem? Is that a good use of money? So, you know, management perceptions can also present some implementation challenges. A preventative maintenance program really needs a champion that supports the change. Oftentimes, champions move up and out and they must be replaced by someone with similar beliefs and enthusiasm in order to keep the program moving forward. So you do have sometimes some of those management perceptions that kind of stand in the way of implementing your preventative maintenance type program. So kind of just putting it all into a bit of a summary, agencies that have implemented preventative maintenance programs have done so for a desire of one or more of these benefits. They believe that the roadway is going to last longer, so they'll enjoy some higher customer satisfaction. But also preventative maintenance programs coupled with that pavement management type of system will help you with better informed decisions. I can start to plan the future, and I can start to plan my budget, and I can start to plan my work. So you can come up with those more informed decisions to improve your strategies and techniques. You'll enjoy an improved pavement condition, and be able to enjoy cost savings and be able to spread your budget around more effectively within your entire network. You'll enjoy increased safety. That's very, very high on the public's list. And you'll also enjoy a program stability. So what I mean by program stability is that you'll enjoy having a good budget management future type of program, to whereby your program of preserving your highways enjoys stability. Okay. So kind of to summarize, you know, again, some of those challenges can be in that public perception, and some of these challenges can also be in management perception. If the managers who manage the agencies on up maybe to the board of directors and so on, if they're still stuck in this worst first scenario, or politics is still kind of driving some of your decisions, you know, those methods, it's been proven, really aren't effective to being able to preserve your pavements and have a really good working system. Okay. So just another polling question here as we kind of wrap up this first segment. If we can bring this up, does your agency have a preventative or corrective maintenance program? If you were to classify your agency, are you more into prevention or more into reaction, or you don't know?
So you should be seeing the polling question on your screen now. Looks like we're getting quite a few people to respond. We'll give it just a few more minutes to let everybody get their answer in. Okay, I think we'll go ahead and end the polling and go ahead and display the results.
Okay, good. You know, that's good. I applaud everybody that has a preventative maintenance program, and I wished if we were in person, I'd like to have the dialogue, and I usually have quite a bit of dialogue during this workshop, because I would like to be able to kind of discuss, you know, those who have the preventative maintenance program, do you have some kind of a management system? And it looked like our earlier polling question indicated that a lot of you maybe do, and how that kind of goes hand in hand and helps you plan your work. So, but that's good. I'm glad to see many do have a preventative, or they think of their programs as more preventative than reactive. Okay. So let's do this. We've gotten past our first part of this thing. We've been able to kind of talk about materials and why it's important to have good design, good construction, and good maintenance practices, and what a pavement management system might do for us. And we've also then talked about how we can go about classifying our roadways to where we can do preventative maintenance rather than corrective maintenance. And we've talked about how we could kind of also kind of classify or rate our roadways through this PCI index type of concept. Let's go ahead and take about just a little 5-minute break, get up and stretch.
Okay.
Okay. So I want to kind of take this one step further now. And when we talk about pavements, I want to talk about distress identification. And so what we want to learn is to recognize asphalt pavement distress. We also want to know the causes of those main types of distresses, because if we know the cause, we can provide the fix. And then let's determine which pavements are good candidates for pavement preservation. So when we look at pavement condition, let's define what we mean by pavement condition. Typically, a discussion of pavement condition is thought of what can you see on the pavement surface. But as we've indicated, what you don't see can be more important in determining how the pavement is performing and where the pavement sits on that deterioration curve. So when we talk about functional performance, we can think of functional performance mainly as ride and safety. So aspects of ride quality include smoothness. It also includes noise. Safety includes the friction. of the pavement surface. It also talks about the removal of standing water. And so pavements that rut exhibit standing water, and it becomes a real safety issue because of hydroplaning. So what are some indicators of pavement functionality? Well, we can think of ride, rough ride, wet weather crashes, standing water, noise, ride quality, surface friction, and surface drainage. And rutted pavements, I have found that standing water and hydroplaning crashes attract the attention of lawyers. And you might be faced with having somebody coming through the door saying, I've crashed my car and severely injured myself because your pavement was in poor condition from a functional standpoint. Structural performance refers to load carrying capacity or load carrying ability of the pavement. We can look at this indirectly by measuring the pavement response to loads. And we can actually load test pavement. I'm going to show you that in just a moment. We can test its overall strength, and we can actually get a handle on testing the strength of the individual layers of the pavement. So we look at our pavement, kind of our cake mix. We had the asphalt on the top, our base layer, our sub-base layer, right on down to the original ground, or original soil. We can also see signs of the pavement structural capacity in the distress visible on the pavement surface. Distress, such as cracking and rutting, and surface deflections can be visible. However, pavements, we know now, begin to deteriorate long before they show any visible distress. We all know that pavements, once we put them down, they start to deteriorate immediately. That is through like environmental conditions, temperature cycles, and moisture infiltration, and repeated load application cause incremental damage to pavement layers. So this cumulative damage eventually results in visible pavement distress. And we can think of our asphalt pavements as a flexible pavement. Kind of think about it a little bit as a rubber band. You can stretch the rubber band and it comes back to its original shape. Flexible pavements are much the same way. They actually deform, and they'll stretch, and they'll kind of come back to their original shape up to a point. And after they really start to wear out, they can no longer come back to their original point and stretch. And that's where we'll start to see visible distresses. So some of the techniques that we can use to assess pavements, with these performance indicators in mind, what types of field surveys can be used to assess these performance conditions of the pavement? Okay. Visual distress surveys give an indication of current functional and structural conditions. So we can look at the type, the severity, and the extent of the visible distress, and we can record that as part of our pavement management system. We can look at roughness or friction surveys, and these are functional related type of assessments. We can look at drainage evaluations. This can be helpful in preventing structural problems. And I know that when you go out and walk the roadway, I've walked the roadway in my prior life, and paying attention to making sure that cross drains are not plugged and you've got good drainage really makes the pavement last longer. And we can also do deflection testing. It can be used to provide information regarding the structural condition of the pavement and what some of those underlying layers are doing for us. So when we look at pavement condition, we can do road condition surveys. Current road conditions are very important. These road condition surveys can vary from simply walking or driving the roadway to more sophisticated equipment. And again, we don't want to get wrapped around the axle. We don't have to have a lot of sophisticated equipment to go out there and determine what the condition of our roadway is, and try and also start looking at where our pavement is starting to distress. So we can look at pavement testing from the standpoint of ride comfort and the structural adequacy. And there's methodologies to go out there and do testing that's destructive and non-destructive. So for instance, some of the tests that are done to the pavement to look at the structural capacity don't tear up the pavement, such as a falling weight deflectometer. Sometimes you have to go out and core the pavement if you need to see what's going on underneath the pavement. And so you go out with like a 4-inch core. Sometimes even a 10-inch core is used, and you can core the pavement core down through the various layers of the pavement and really kind of get an indication of what the pavement is doing and what it consists of. Sometimes these tests can be expensive, but these tests are basically used many times for the design or rehabilitation of projects, so you can come back and design the roadway pavement section properly. And certainly when you're reconstructing the roadway, this testing is very important. So pavement distress and deflection is important. You can, when you're looking at pavement distress, it's usually performed by one or two people where you can walk the roadway or use a slow moving vehicle to actually look at the surface of the pavement to see what kind of distress that you have. There's also ways to determine the pavement distress and deflection by an automatic means. You can do this visual survey. There's very sophisticated systems out there. ITD has one, I call it the Star Wars van. We'll see a picture of that in just a moment, where they can actually run this van down the roadway and they can look at cracking, rutting, distortion, raveling, and they can record all this information and put it in their pavement management system. And then you can also then look at ways of how pavements are distressed by the ride comfort or smoothness. You can use a profilograph. There's this thing called the California profilograph, or you can use a radar type of system. It's pretty sophisticated and it's mounted on a glorified golf cart. So here's the two systems. You can see the top one, that's called the California profilograph. You have to just push this thing down the roadway. There's a tire that runs on top of the roadway surface and it records the smoothness. So again, that's a functional classification of how your roadway is performing or what the condition of your roadway is. The bottom one is the glorified golf cart. Run this thing down the highway and it will use radar to determine the smoothness of your pavement. People really love the golf cart. They don't like the California profilograph, especially when you're pushing that thing uphill. Pavement distress and deflections. You can look at the structural adequacy through non-destructive testing. This is a picture of a falling weight deflectometer. It uses weights and sensors to determine the condition and the load carrying capability of the pavement and base materials that support the pavement. So this device basically goes out there. You set it up on the roadway. There's sensors that you put down on the roadway. And there's this big weight. People call it the thumper sometimes. It's this big weight that falls and it kind of shocks the pavement. And through programs and electronics, you can determine what the strength of your pavement is. And also you can determine to a relative degree of accuracy how strong your base or sub base is and what the condition of that material might be. It can be a bit expensive to run one of these things, but if you're real serious about designing, if you're going to get into a rehabilitation project on your roadway, sometimes it's really nice to know what the condition of your roadway is, especially if you're going to start adding layers to increase the structural capability of the roadway, layers of asphalt. It's a good idea to determine what you've got, because if you can't determine what you have, you'll find yourself just out there kind of guessing. This is just a picture of that Star Wars van. I think there are companies actually that can come out and do condition surveys for you if you want that done. But this thing runs down the roadway, detects things like the rutting, cracking, roughness. It'll do the cross slope. It'll put your pavement on a GPS system to where you can go out and actually pull it up later in mapping programs and so on. And you can actually pick up features like roadway signs, guardrail, and so on to really get a total picture of your whole roadway and how you can put that all together into a management system. Most people probably aren't going to use this, but it is available if you're ever interested. Here's a picture of a pavement skid tester. It determines the surface resistance. We're very interested in in knowing sometimes what the surface is doing from a frictional standpoint, and helps us maybe determine when we're going to do seal coats and where we want to do seal coats. It also is also used when we're diamond grinding concrete pavement. A lot of us really don't have concrete pavements. So those are just some of the things that that can be used to help determine how our pavements are distressed and how they have deteriorated. So in order to apply some appropriate pavement preventative maintenance program at the optimal time, remember our whole goal is to the right thing at the right time on the right section of roadway. So in order to apply the appropriate preventative maintenance at the optimal time, a good understanding of a typical progression of roadway deterioration has to be understood. So no matter how well constructed a pavement is, it's going to deteriorate over time as a function of repeated climatic cycles, environmental, and traffic loadings. When trying to determine appropriate pavement measure, we want to ask, how do I expect the pavements to perform? We want to get a really good feel for a typical performance of a pavement in a particular location for climate and traffic loading. So variation swings can be great in pavement performance due to changes in many characteristics such as the environment, the design, and the construction and so forth of that pavement. So preventive maintenance prolongs the pavement in an economic manner. So you can see that this pavement is deteriorating quite rapidly. I mean, we can see that it's not in very good condition. It's probably gone out of the preventative maintenance area on the curve and is probably more into the corrective action. So distress categories. How does construction, you might ask, contribute to distress? Well, if we have poor construction practices, we can have rough joints, poor workmanship of the pavement will contribute to roughness. We can have segregation of the plant mix pavement itself. It's kind of falling apart. It's not well graded. And then we can have poor production of the hot mix asphalt coming out of the plant, which with an incorrect asphalt content and just all kinds of things, incorrect gradation of aggregate. So construction methodology itself can contribute to distress or premature distress of the pavement. But our big ones are load and the climate or environment. So when we think about load-related stresses, we can think about different types of cracking. If you go out and look at the pavement and how it's cracking and what it looks like, it kind of can give you an idea of what's causing the distress to the pavement. Whether you have like just a pavement problem or whether you've got base layers that are failing, whether you've got poor drainage and so on and so forth that we need to talk about and look at. So we can look at fatigue cracking, alligator cracking, potholes that are showing up, rutting, edge cracking, and shoving are just some of those load-related type of stresses. And I will tell you that you can go out on the roadway, I've seen this, and if you've got a really poor drainage or a cross drain, it's not allowing the sides of the road to drain away. That small section just above that poor drainage feature will deteriorate where the rest of the roadway looks good. So drainage is very, very big in combating load-related distresses. So here it is. Here's a picture. Okay, this is a picture of what we would call fatigue cracking. Okay, it's got some kind of a structural failure to it, and you can see it's in the wheel path, and you've probably got something that's going on with the pavement or the base layers themselves, and it's losing its strength. So this is again is kind of falling out of the preventative maintenance category, and you're getting into that reactive or corrective maintenance. Here's another picture of fatigue cracking. So pavements that exhibit this typically are starting to have some kind of a problem with their base. I want to show you a picture of longitudinal cracking. And so when we look at this type of cracking, it's typically caused by overloading. So the pavement has failed basically because of repetitious loads. And so that's why it's important too to have like some weight control type of processes. I know, the people get out sometimes and they set up scales to weigh the trucks to make sure that trucks are running legal. Here's a picture of thermal cracking. You can see the green line. And the goal is to keep this crack from propagating to the bottom of the plant mix. Okay. And contributing to premature failure of the roadway. So if we can seal this crack and keep it from propagating clear to the bottom of this layer of plant mix, then we have a better chance of preserving the pavement. But that's just kind of a cross section to show you what a thermal crack might look like. So subgrade and base, pavement design problems can contribute to pavement rutting. You can have failure of subgrade and base that will cause pavement rutting, but also pavement rutting can come about through the pavement layer itself, the plastic flow of the material in the mix design. Perhaps we didn't have very good consolidation or compaction of the roadway when it was built. So guess what? The cars and the trucks are going to compact it further for you and cause ruts. And pavement rutting can really come about through severe surface wear as well. So when we talk about rutting and a plastic flow, either we've got crappy material, in other words, we didn't have really good graded material, or we didn't have material that was crushed properly that gave us a good angularity of the pavement particles, because most all of our strength comes from that point-to-point contact of the aggregate particles, or we had a bad mix design. And one of the culprits of the bad mix design is too much asphalt was put into the mix design. So the mix is going to have more plastic flow in nature. And so as we have repeated loads go over the plant mix pavement itself, if we've got a bad mix design, maybe with too much asphalt, rutting will start to show up. So here's a picture that shows rutting, and it's pretty easy to measure. You just take a straight edge and go out onto the pavement and determine how much rutting you've got. And again, when we talked a little bit earlier, this is on this type of pavement distress, rutting can cause a really big safety problem. I know some instances where cars have skidded, hydroplaned, and gone out of control, and then the lawyer comes knocking at your door. Here's a pavement that is really badly rutted, and I would say that the pavement itself has a real problem as far as it might have some, it might be a really bad mix design. And you can see that travel lanes are severely rutted versus the passing lanes. It looks like this is a 4-lane section. Probably a lot of heavy truck traffic contributes to this really bad rutting. Another type of pavement distress is potholes. It's really can be severe. It's kind of a result of other types of distresses. So alligator cracking. Potholes start with alligator cracking. Potholes can start with raveling. Potholes can start with failed patches. And potholes can start when we have a thin or weak type of a pavement. In other words, the pavement wasn't adequately designed to carry the load. And so repeated loads will start potholes. So here it is, typical pothole. We've all seen those and we have to combat those. Note the alligator cracking that's around the pothole. So this all started with some kind of alligator cracking took place. And if we didn't do any preventative maintenance out there, if we weren't able to take care of it right away, then as time goes on, water gets in, freeze thaw takes place, and the pothole is born, and the pavement sections of the pavement come apart and come out. And And the traveling public really loves potholes. Here's just another picture of a pothole. Edge cracking is another type of pavement distress that we're combating. And so there's poor lateral support on the edge of the pavement that contributes to edge cracking. Many times edge cracking is caused by some kind of a settlement of underlying material. And the settlement can be brought about by having either poor drainage along the roadway, the water is seeping in on the edge. Frost heaves will certainly contribute to edge cracking. And we can have shrinkage or drying of the soil if we've got bad soil that either swells or shrinks. It can contribute to edge cracking, and it really is aggravated by high traffic levels. Also, narrow lanes, and if we're running a lot of truck traffic, we'll see a lot of edge cracking. So here's a picture of edge cracking. You can see right along the fog line, this is probably a pretty narrow section of pavement. Doesn't look like there's much shoulder there. And so you probably got traffic loads that run pretty close to the edge. You might have some drainage problems along here too that contribute to the edge cracking. Shoving or washboarding of pavements. A lot of times shoving of plant mix pavements will take place at intersections where we have a lot of turning movements, a lot of truck traffic. We'll start to shove the pavement around. And that's why I'm seeing more and more intersections in higher traffic volumes in urban areas. More and more intersections are being constructed with concrete rather than asphalt pavement. So they'll do asphalt pavement coming up to the intersection, but the intersection itself is done with concrete. So these occur at intersections, also steep grades where there's a lot of loading onto the pavement to try to climb hills from the traffic. Ramps. Shoving can be caused by, again, weak or unstable mix if you've got a bad mix design or if you've got some kind of unstable base. And so there's a nice picture of shoving. You can see that the plant mix pavement is being shoved up against the hard object, in this place a curb here. And to go in and fix this is going to be quite expensive. You pretty much have to go out and remove the pavement, either mill it out or just remove it totally. And you find yourself more into a big rehabilitation project or some kind of a total reconstruct of the pavement. So climate-related stresses will cause block cracking. The pavement itself will just crack in big, huge, gigantic blocks. And it's interesting when we see block cracking, or in many cases thermal cracking, it will be kind of at a regular interval or interspace. For instance, going down the roadway, thermal cracking, the pavement might crack about every 40 feet or so. And so another pavement stress that's caused by the climate is weathering or raveling. Thermal cracking can come about if the pavement that was put down didn't have the proper grade of asphalt. You know, asphalt just doesn't come out of the ground and go through a distillation project and one size fits all. There's various grades of asphalt. And so you want to be able to pick the grade of asphalt that works the best for your climate. And sometimes not everybody keys in on that and they pick the wrong grade of asphalt. And so the asphalt is going to get brittle and hard in colder climates, and it won't do well in thermal cycles as the pavement heats up and cools down, and you'll get thermal cracking, and that takes place at a regular interval in the highway. So block cracking really divides the pavement into those rectangular pieces. They can be, you know, a foot by foot to a 10 by 10 foot type of cracking. It can oxidation can cause block cracking, as well as low asphalt content in the mix design. And also aggregates that are very absorptive. In other words, they will suck up the oil as it's mixed together with the aggregate. if you have highly absorptive aggregates, then a lot of the oil will be sucked into those aggregates, and you don't have enough oil left over to and essentially just glue the rocks together. So it's very important when we do plant mix and mix designs that we understand not only how the aggregate behaves from a gradation standpoint. Remember at the beginning we talked about sieves and sieve analysis and sizing the aggregate. We also want to determine how absorptive our aggregate is, because that will be very important when we select the amount of asphalt that we're going to put in to the mix design. So here's a picture of just typical block cracking, and just like the name denotes, it just cracks and blocks 1 foot by 1 foot to 10 foot by 10 foot, all various sizes, but they seem to be fairly uniform in size. Reflective cracking, another pavement distress that's important to us, is caused by the movement of the underlying layer. And so vertically, we have reflective cracking that takes place from loading. And so, or longitudinally is really a better word. It goes up and down the length of the pavement. It's typically caused by loads, and we saw that a little bit earlier. And horizontally, reflective cracking is done with thermal cracking. And so if we can't take care of cracking, and we put another pavement layer on top of an existing pavement that has these working cracks, or it's caused by movement of the underlying layers, typically then those cracks will propagate up through our new plant mix pavement, and we'll have that crack itself. And so we're really kind of not solving it totally when we put on a new layer of pavement. It'll temporarily, the cracking will go away, but these working cracks, or these reflective cracks, will eventually work their way up through the new pavement layer. Some people have tried to combat this by putting down some type of stress absorbing membrane before they do their overlay, and those tend to work reasonably well. I don't know if they cure the problem totally, and so it just all depends upon the type of material you're going to put down and the type of membrane. So it's kind of something to think of if you're going to try to combat reflective cracking. So here's just a picture of reflective cracking. You can see that we've got some edge cracking as well, but reflective cracking does take place, and notice that it's usually at pretty uniform intervals going down the roadway. So longitudinal and transverse cracks. Transverse cracking is generally almost always thermally induced, okay, by the environment. Pavements, they expand and contract over time. Longitudinal cracking is typically shows up because of poor paving lane joints. When contractors put the joint together, they don't do a good job of compacting the joint, and so in a very short period of time, you'll have paving lane joints that will show up the entire length of your pavement. And typically, it's just poor joint construction, mainly poor compaction. So again, here's a picture of longitudinal cracking, and you can see this makes a lot of sense. Typically the roadway is built a half at a time, and so I would say that not a very good job was done when the joint was constructed. And so again, it's really important to try to be out there and to have some kind of a quality assurance program or testing program, inspection type program in place when new construction is taking place, because once the contractor leaves, you have to maintain it. Here's just a picture of some transverse cracking, probably thermally induced. When we think about the type of pavement distress that we put in the category of weathering or raveling, we think about aggregate and how we're losing the aggregate on the surface of the pavement. Weathering and raveling can be caused by poor compaction. We've got cold, wet weather construction. So construction took place at the wrong time of year under bad climate conditions. Dirty aggregate will cause raveling. We don't have good adhesion of the asphalt to the aggregate. And so if those aggregate particles are not well coated and the asphalt cannot stick to the aggregate particles, then the aggregate will start to strip away and will ravel. Called stripping is usually the term that's used with that. If the asphalt is low, if the content of asphalt is low in the mix design, that will contribute to raveling as well. Or if the mix was overheated, if it came out of the plant and the mix is cooked, then it won't be long before we see raveling and weathering taking place on the plant mix itself. And so if you're out there doing construction and you're inspecting the project and you have a load of plant mix that shows up that looks like it's cooked or brown, something's really wrong at the plant. And so it's best to just shut everything down and try to figure out what's going on. I've been on projects before where the first load of mix came out, it was cooked brown. Unfortunately, the people who were there looking at the project really weren't well trained and they didn't know what they were looking for. Contractor's going to go ahead and just put it down, and they did. They put it down until somebody finally came along and said stop. Got into quite a situation, and then eventually the contractor had to remove all that overcooked plant mix and replace it, because it wouldn't be long before raveling and weathering would take place. So here's kind of a picture of a pavement surface where you can see weathering and raveling, and you can see that the aggregate is exposed. It's not, the particles are not well coated. Like if I were to back up here, nope. Yeah, you can see on this surface, even though we've got cracking, you can see that you don't see aggregate particles standing on the surface like you do when it's raveled and weathered like this. And the asphalt has departed from around the aggregate. So perhaps the aggregate was dirty. The plant mix was cooked, just a number of those things that I talked about earlier. Okay. So here's another pavement that's got some raveling that's taking place. You can see if we let this roadway go much longer, the raveling is really going to take place. You'll have some potholes that will start to form, and it's going to cost more money to maintain this pavement as time goes on. Here's another picture of weathering and raveling. Kind of we might have a longitudinal joint that's given us some problems here, but you can see that this pavement will deteriorate quite rapidly from this point forward. So other distresses that are in our pavement is bleeding. We've probably all seen some kind of a bleeding pavement where the asphalt, it's over asphalted and the asphalt kind of flushes up to the surface. Bleeding is kind of hard to combat. You try to blot it. Some people try to blot it maybe with some sand or something, but it's kind of hard to correct. Other distresses are bumps and sags in the pavement. A lot of times the sags are associated with utility cuts. Pavement, other distresses are corrugations and shoving. We've talked about shoving a little bit earlier. Depressions, lane shoulder drop-offs, patching and utility cuts can be real big. Another workshop that I do, we talk about utility cuts and how when the pavement is cut and the trench is dug, you lose a lot of the support of your underlying layers below the pavement. So when it's patched back together, typically it could be poor compaction of the material that's put back into the trench. It's not compacted properly, and it won't be long before you have some kind of a sag or dip in the pavement. Polished aggregate, it's kind of a function of the asphalt leaving the aggregate. And so you just have that surface of the aggregate that's exposed and it's polished up by the traffic. Railroad crossings are real big for pavement distresses as the pavement bumps up to the railroad crossings itself. And then also we have like slippage type of cracks, where we have working cracks that traffic loading, especially if we have, say, steep uphill grades and so on, we might have cracks that are caused by the actual pavement kind of shoving and slipping itself. So those are just some of the other distresses. So when we look at preservation candidates for various types of pavement fixes, we can use preservation treatments, but we want to apply those treatments when pavements are in fairly good condition and that we have corrective actions that are required only on a small area of the total pavement. So those are good candidates for our preservation program. Okay. Pavements that are not good candidates for preservation are pavements in poor condition. You've got to do some substantial repairs, and you've got real bad structural problems with the pavement. So again, sorry to bring the curve back up, but I can't pound this home enough, is that preventative maintenance is in this upper part of the curve when our PCI index and our critical PCI was right in the 60 to 70% or 60 to 70 number range. And so we want to stay on top of things and do preventative maintenance. It's going to cost us a whole lot less money. And corrective maintenance in the form of rehabilitation or construction takes place when the curve deteriorates rapidly down to this point, and our PCI number is a lower number. So when we get right into that midpoint of that curve there, that critical PCI, again, the curve is not linear and our pavements will deteriorate very rapidly. So we want to be able to recognize pavement distresses. Okay. So we've made an attempt to really kind of try to recognize some of those asphalt pavement distresses and what some of the causation is. We would like to know the causes of the main types of the distress and determine which pavements are good candidates for pavement preservation. So again, pavement cracking that's left unattended is going to lead very quickly to expensive pavement defects and repairs, and you'll start to see your money kind of go down the drain. So with that, let's open it back up. Lori, are there any questions or comments? Again, this is kind of a bit hard in the virtual environment because I usually have a lot of interaction going back and forth on this. But if you have any questions or comments or thoughts, I'd like to hear them.
If you'd like to ask a question, just go ahead and click the unmute on the bottom left side of your screen. Or if you can use the chat box if you'd like. Doesn't seem like we have any questions right now.
Quiet crowd today. So,
It is.
Well, and that's it with virtual. So, so of all those examples that I showed you, do any of those look familiar as far as the types of pavement distresses that you have on your system? Are many of you faced with shoving and rutted pavements?
Christopher Owens put mostly the alligator.
Okay, yeah, that's the most common type.
And then Stephen Morgan said yes to your last question, and Dallas Paul said no.
Okay, all right. Yeah, some do and some don't. Alligator cracking is probably the most prevalent type, and many times it's not so much of a pavement problem, but you've got some kind of underlying problem in the base or the sub base. And a lot of roadways were built over time that there wasn't maybe a lot of design that was put into the roadway and the roadway sections. And so one layer was just built upon another layer, which was just built upon another layer. And, the roadway just kind of evolved from that point in time. And then so sometimes, as truck traffic increases, and I know loading for truck loading is increasing in Idaho, but sometimes the roadway becomes overloaded and you end up with a lot of distress, pavement distress in the form of maybe alligator cracking. And you just about have to go in and at some point maybe be faced with some kind of a major rehab or reconstruction type project. And it's nobody's fault. It just the way the roadway kind of evolved over time.
I don't see any other comments in the chat box.
Okay. Well, we're coming up on the top of the hour, Lori, and I think I'm right at the midpoint here.
Okay.
And so we probably, if it's okay with you, we probably could call it a day
Okay.
and pick back up tomorrow.
Yes, and everyone will still use the same link that you did today to access tomorrow's class. We'll be starting at 9 a.m. Mountain Time. If you have any questions, feel free, like I said, to put them in the chat box, or you can contact me directly. And I think unless anyone has questions, we can go ahead and wrap up early today.
Okay, give you a few minutes of your day back. And again, thanks for hanging in here. I know this virtual is kind of a little bit.
Yeah, it is.
It is. A lot of times I do have a lot of interaction going on, and we have a lot of dialogue. So that's why maybe we're a few minutes ahead here. So anyway, if you do wake up in the middle of the night and have a question or something you want to bring back to us tomorrow, we'll be certainly very happy to discuss it and answer it for you. So with that, I'll turn it back over to you, Lori.